Don't forget to subscribe, comment and like. Welcome. This is from 2 Maths, Chapter 1. We will do Chapter 1 to the last topic, step by step. So we start with the first topic, which is cubes and the cube roots of numbers. So we start with cubes of numbers. So to cube a number is simply to multiply the number, that number, simply to multiply that number by itself two more times. Now, for example, when I'm saying 2 more times, I have this number. Let this number be 5. I want to get the cube of 5. So what do? I multiply this number by itself 2 more times. Already I have 5. So 5, another 2, 5 is 5 times 5. So 1, 2 plus this, there are 3 of them. Therefore, a cube of a number is to multiply that number by itself 2 more times. 2 times. So 25 times 25 times 5 times 5 times 5, the answer is 125. So the cube of 5 is 125. So generally we can say that the cube of a number, say A equal to A times A times A, right? So A times A times A simply means A raised to power 3. Therefore, we use A cubed to power 3. The cube 3 here means that A times A times A 3 times. So 3 here shows that A is multiplied by itself 3 times. 3 times. It is multiplied by itself 3 times. Very good. Methods of finding the cubes of numbers. We have 2 of them. Number 1, we use multiplication. And number 2 is the use of a mathematical table. So these are 2 methods that we use to get the cubes of numbers. We start with number 1, multiplication. So in multiplication, we are going to use this example. Find the cubes of the following numbers. A, we have 10. What is the cube of 10? The cube of 3 and the cube of 20. So we start A. 10 cube simply means 10 raised to power 3. Therefore, 10 raised to power 3 means 10 times 10 times 10, 3 times. So 10 times 10 times 10, the answer is 1,000. Therefore, the cube of 10 is 1,000. The cube of 3 means 3 times 3 times 3. And the 3 times 3 times 3 means 3 raised to power 3. So the cube of 3 is 3 times 3 times 3, and the answer is 9. B. C. The cube of 20. The cube of 20 means 20 raised to power 3. Therefore, 20 raised to power 3 is 20. times 20 times 20. And the answer is what? 20 times 2400, that is 80,000. Right? That is it. What if D, we have 0.5, the cube of 0.5. So 0.5 simply means 0.5 times 0.5 times 0.5. We have 3 decimal places, therefore 5 times 5 times 5 is 125. So we must have 3 decimal places. I hope you have learned properly decimals in form 1. Therefore 1, 2, 3, we put a 0 here, and that is the cube. The cube of 0.5 is 0.125. So it doesn't matter whether it is a fraction or a decimal or a whole number. You can just multiply that number and you get the cube of that number. Use multiplication method to find the cubes of the following. Number 1 is 13, number 2 is 1, 2 over 3, number 3 is 4.5. So the cube of 13 simply means 13 times 13 times 13. 13 times 13 is equal to 13 raised to power 3. You get the answer. 1, 2 over 3 times 1, 2 over 3 times 1, 2 over 3. First, you change this fraction into improper fraction. So how do you change this fraction into proper? 3 times 1, 3 plus that is 5 over 3 times 5 over 3 times 5 over 3, and that one gives you the cube of this number. 4.5 times 4.5 times 4.5 gives you the cube of 4.5. Number 2 is mathematical table. Now you have seen that, for example, if I have a number like 2,403 times 2,403 times 2,343, this sum can take you 10 minutes to multiply itself. Therefore, it is tedious. Now, the mathematical table gives us a very easy way of getting the squares, the cubes of numbers. Therefore, and the mathematical table provides the cubes of numbers from 1.000 to 9.999. So any number that is not between 1 and 9.999, you must write it in a standard form. For example, if you want a cube root, if you want a cube of 450 or 45, the cube of 45, it does not exist in the mathematical table. Therefore, you must write this number in standard form, of which I hope you learned in form 1. And if you did not, I will show you, I will take you through that. So let us go straight to we want to learn the mathematical table. I know you have done the squares and the square roots in form 1, but I will also assume that you don't know, and then I will take you through how the mathematical table looks. There are things you must understand. As you can see, the table of cubes has got 3 columns, 3 main columns. The first column is the one which has X. This column with the black here, 1.0 down, this column here is called the X column. We call it the headed. Column headed X, the heading, these are the headings. So this is X. Now we have these other columns that begins 0 to 9. 0 to 9. We call it the main columns from here up to here, the main columns. And then we have these columns that starts at this end, 1 to 9, right? We call it the mean difference columns. We call it what? Mean difference columns. Mean difference. Mean difference. mean difference columns. So that's what you must know for us to use this for figure effectively. Now, using a mathematical table, find the cubes of the following numbers. A is 1.4, 1.4, B is 2.37, C is 4.865, and D is 4.8659. So we want to go to our mathematical table for figure and find the cubes of this. Whenever you see 1.4, this number is the same as 1.40. So don't struggle looking for 1.4. 1.4 is the same as 1.40 because this 0 does not have any meaning here, but it is important for you to know that 1.4 is the same as 1.40. If you want 1.5, you will not find it. What you will find sometimes, it is 0. That's this one, and this is the same. If we want a cube of 1, you will not find it unless it is 1.0, right? So 1.0 and 1 are the same. So let us go straight away and check our for figure. So we want the cube of 1.4. So 1.4 is here, right? So 1.4, it means it is 1.40. If we wanted the cube of 1.42, 1.42, 1.4, and then 2, we come here. But now, the cube of 1.4 is the same as the cube of 1.40, 1.40. So, our answer is 2.744. So, the 1.4 cube is 2.744, and that is the answer, correct. Next one is find the cube of 2.37. 2.37. So we go to the first number we check. You see the X column has only 2 digits. So we start there. We want 2.3. So we find 2.3 here. 2.1, 2.2, 2.3. Right? So we stand there. And then we move to the main column. We look for 7 because we have 2.7 and the answer is here. But now we 2.3, the answer is here. Now we want 7. 7 is here, right? So 2.3, then go along to where we have 7. 7 is here. Therefore, the cube of 2.3, 7 is 13.312. The next number is C. Find the cube of 4.865. So we go to X column. We find where we have 4.8. We go to the main column and see the number where we have 6 at the head there. And then we read the number there. And then this 5, we find it in the difference column. 4.8. So we find 4.8 is here. 4.8, right? And then now we go to the next one was 4.86. We go across and where we have 6. Our 6 is here. This is where we have 6. 6 is here. So we come down to where we have this 4.8 and then 6. We note it down. That is 114.79. You can see it is 114.79. Next, we go across to where we have the last digit, which is 5. Now we move further along the difference column where we have 5. 5 is up there, so you check 5 up there. 5 is here, and check the number that is corresponding to 5 at this point. That is number is 35. So 35, and then you are told to do what? To add. So the difference we add. For cubes, we add. So where do we add that? So let us check. So at the difference column, we have obtained that at 5, we have 35. So 35 at the difference column is the same as 0.35. Is the same as 0.35. That is very important for you to know. Therefore, we want now to add 0.35 on this number for us to get the accurate cube of 4.865. Therefore, add 0.35. This plus this is 14. This 10, 11. This 5, 4, 1. Therefore, the correct cube of 4.865 is this. 115. Why 15? What was that? So the cube of 4.865, we have obtained it from the x column, and the main column is 114. When we read 4.86, we obtained 114.79 up to this point. Now we went across to the difference column where we have 5 as the head there. That the number that was there is 35. So 35 is the same as 0.35. So this is the number we are supposed to add. So let us add this number, 0.35. Remember, adding decimals, this is how we add them. So this is 14, this is 10, 11, this is 5, 1, 1. Therefore, it means that the cube of 4.865 is 115.14. Now, our number C was 4.8659. You can see that this number is, how many numbers are here? Digits 1, 2, 3, 4, 5. And our table is called a 4-figure. If you have not seen, look at this. It's called 4-figure. Therefore, we cannot use a number that is more than 4 figures. We are not going to use this whole number the way it is. Therefore, this number is the same as 1, 2, 3, 4. You stand here, and this is 9. Can you round off? It will increase this one by 1, and it will become 6. Therefore, 4. The number we are going to look for in the table is 4.866. We want 4 figures. So let us go straight and take this number in the 4-figure. So in the x column we have 4.8, and then we have 6. So we go to where we have 6. This is where we have 6. That is 114.79. That one you write it down. Write it down. Now once you have written it down, you move across to difference column. This is 1, 2, 3, 4, 5, 6. So when you start here, the 1, 2, 3, 4, 5, 6. So in our 6, the number we have, the last digit is a 6, and at the 6 we have 42. So 42 is written as 0.42. So that is the number we are going to add to this answer that we obtained here. So we add 9 plus 2, that is 11. 11, 12, 5, 1, 1. So 115.21 is the cube of this number. So that's how we obtain. But now we want to look at how do you obtain cubes of numbers that are not that are more than 10 and less than 1. So cubes of numbers less than 1 or greater than 10. Like I told you that the 4 figure only gives us the cubes of numbers 1.000 to 9.999. So how do we obtain the cube of a number like 20? How do we get the cube of a number like 0.00045? How do we get the cube of that number? Very good. So when you have a number like A, for example, 2341, you want to get the cube of 2341. This number is not there in the 4 figure. Therefore, what you do, you must write this number in standard form. How do you write a number in standard form? 2341, our decimal is here at the end. That's where a whole number always has the decimal point towards the end. So we want writing standard numbers in standard form. You must ensure that the decimal point is going to be between a number that is between 1 and 9. So we take this number backwards, 1, 2. If I stop at 2, this is 23. I have not made this number a number between 1 and 9. Therefore, I go another step. How many steps have I moved backwards? 1, 2, 3. So the standard form of this number is 2.341. How many times did I move backwards? 1, 2, 3 times 10 raised to power 3. When you move from a decimal point then backwards, you go backwards, the power of 10 is positive, right? For example, let me take you 0.00472. We want to write this number in standard form. How do you write it? Our decimal point is here. So because our decimal point is here and the number we are looking for is a number between 1 and 9, we are looking at that number inside here. Therefore, we move to the right like this. 1, 2, 3. Why did I stop here 3? Because if I move the next step, I'm going to have 47. 47 is not a number between 1 and 9. Therefore, I stop at 1, 2, 3. So the correct standard form of this number is 4.72 times 10 raised to power negative 3. Why? When you move from the decimal point to the right, the power of 10 is negative. I hope I have reminded you that. Now, once you have this number, now you can go straight again and do what you have been doing from the table. You check 2.3, 4, and then 1. 4.72. You get the cube of that number. Now, example, find the cubes of each of the following number. I have given A 2341, 2341. We have already written the standard form of this number. But remember, 2341 is cubed. So we have just written in the standard form. We have not changed this number. It means this number is cubed. Even this number is cubed inside here. Right? So go to the table, read the cube of 2.341 because now you know how to get that. Now, once you are there, you read that the cube of this number is 12.829. I have taught you how to get it, so I'm not going to go back here. So the cube of 2.349 is this times, what is the cube? This one is 10 raised to power 3, right? The cube of just multiply this times this. What is that? 10 raised to power 9, right? Therefore, this is the answer, but you cannot leave the answer in this way. If you want to leave in standard form, it implies that 12, write this one in standard form, it is going to give you 1.2829 times 10 raised to power 1. That is this number only. And then we have times 10 raised to power 9. So this and this, it will give you a total of 1.2829 times 10 raised to power 10. So this is the answer, because writing this number will give you a very long and a very big number. Therefore, it is okay you read it in standard form. So let us look at this one. 0.004, this one is not in a beautiful figure, so we write it in standard form. We have written it in standard form here. Once you have written it in standard form, you go to the to the table, the mathematical table. You read 4.72, and that one gives you 105.15. Once you read the cube of this is 105.15 times, that is the cube of this number only. What about the cube of this? This times this is 10 raised to power negative 9. Right? We are done. But if you want to write this number in standard form, this number is not in standard form. So what do? You write this number in standard form. You are going backwards, so that is 10 raised to power 1.0515 times 10 raised to power 2 times 10 raised to power negative 9. So this 10 and this, so this one, if you add a positive and negative, it will remain 10 raised to power 7. So the final answer is 1.0515 times 10 raised to power negative 7. What did I do? Is like negative 9 plus 2. Negative 9 plus 2 is negative 7. Indices, we are going to run about indices that when the bases are the same and we are multiplying, we add the power. This is called the power. So this plus this will give you this. So don't worry about that. You will learn more about that. The cube root. Now we are moving to the cube roots of numbers. The cube root of a given number is the number which when cubed, which when multiplied 3 times equals to the given number. I don't know whether that one will be understood from this example. For example, the cube root of 8 is 2. Why? When you cube 2, the answer should be 8. That's why we are saying this. The cube root of a given number is the number which when cubed, the cube root of a number is the number which when cubed, when multiplied by itself 3 times, will give you the same number of the given number, of that number that is given, of that number that you are looking its cube root. For example, the cube root of 8 is 2. The cube root of 8 is 2. Therefore, how do we know why is that the case? Because 2 raised to power 3 or 2 cube, the answer is 8. I hope that one is understood. So the cube root of a number is denoted by, or the sign of a cube root is this. Wherever you see 3 here, that one represents what? The cube root of a number. So the cube root of x, this is how we find the cube root of a number. So when you find, for example, find the cube root of 27. This means that find the cube root of 27, meaning that give us a number that when you multiply it 3 times, it will give you 27. That's what a cube root means. Give us a number that when you multiply it by itself 3 times, it will give you 27. What number is that? 3. Therefore, the cube root of 27 is 3. How? Why? Because 3 times 3 times 3 will give me this number, which is 27. So we have 2 methods we can use to find the cube roots of number. Number 1 is the use of the factor method, where you express the number given into its prime factors. You express that number into its prime factors, and then I will show you how to get the these prime factors are then written as a pair of 3. equal factors. 3 equal factors. So we have the cube roots of numbers by factor method, and then we will look at how to use the mathematical table for figure. So for example, find the cube root of Now find the cube root of 64, 0.216, 210/27. D is negative 64. So if I don't write this one, find the cube root of this, and somebody asks you evaluate or find this, the cube root. This means this is a sign of the cube root. So this simply means the cube root of 64, the cube root of 0.216, the cube root of 10/27, like that, the cube root of negative 64. So you can be asked to find this like this only, or find the cube root of this. So when you are asked to find the cube root, you should know it simply means this, simply means this one. So let us begin with number A. So first we have said we are using the factor method. You know how to write the factor. We have two ways of writing the factor method. You start 64. The smallest number that will go here is 2, which is 32. You do here 2, 16. You come here 2, which is 8. You come here and again 2, which is 4. Again 2, 2. So these are our prime factors. So 64 equal to 1, 2, 3, 4, 5, 6 equal 2 times 2 times 2 times 2 times 2 times 2, right? So we have written the prime factors, and this is what we call factor method. Once you have written so we are looking for the cube root of 64. So it means we are looking for the cube root of this number. Right, now we have written this number this way. So once you have now this number, the cube root of 64, which is 2 times 2 times 2 times 2 times 2 times 2, you 1, 2, 3, 4, 5, 6, there are 6 of them. There are 6 of them. You group them because you are looking for the cube root, group them into 3. So 1, 2, 3, you group them. 1, 2, 3, you group them. Right? So to get a cube root is pick one here, which is 2 times 2. So it means the cube root of 64, the cube root of 64 is 2 times 2, which is 4. And that is the factor method. Number B, find the cube root of 0.216. Because now we want to write this number in fact using the factor method. First, what does 0.216 mean? It simply means this way: the cube root of 216, how many decimal places? 1, 2, 3 over the 1,000. That's what it means. So this one simply means the cube root. Find the factors of 216 using this method. So that one will give us 2. Now these are the prime factors of 216, and these are the prime numbers of, or the prime factors of, not prime numbers, prime factors of 1,000. 1,000 is 10 times 10 times 10, right? So now I told you, once you have written the prime factors of this number, group them into 3. If you find that you have prime factors and you are looking for a cube root and they don't have a group of 3, then there's something wrong somewhere. So group this one, there are 3 of them, pick one, which is 2. Out of this times 1, 2, 3, pick 1, 3, divided by 1, 2, 3, pick 1, 10. So the answer here is 6 over 10, and that is the cube root of, so the cube root of 0.2216 equal to, this is equal to 0.6. 6 over 10 is the same as 0.6. That's what it means. So you must do this one when you are asked to use the factor method. Now what if it is this fraction? We had a fraction here, the cube root of 210/27. So we want to get the cube root of this fraction. So the first thing you do, write this fraction into improper fraction. This one is mixed fraction. So 27 times 2, 54. 54 plus 10, this is the same as the cube root of 64 divided by 27. So once you have reached there, you write the prime numbers of, or the prime factors, not prime numbers, the prime factors of 64, the prime factors of 27, which will give us like this. 64, it is 2 times 2 times 2, times 2 times 2 times 2, right? 27, it is 3 times 3 times 3. So from here, pick one, that is 2, times pick another one here, 2, pick here. And the answer is 4 over 3. It means that the cube root of 64 over 27 equal to 4 over 3. And that is all. Use of mathematical table to find the cube root of numbers. It seems to be very difficult to find a cube root of a number which you cannot express as the factors or the product of its prime factors. Therefore, the table of cubes comes in and helps us to find the cube roots of those numbers that we cannot express in terms of the prime factors. We do not have a table of cube roots. We don't have a table of cube roots, but we have the table of cubes. So we are going to use the table of cubes to obtain the cube roots. Now find the cube root of this number. The cube root of this number. Find the cube root of 27. You cannot write 27. Although 27 can be written 3 times 3 times 3, you pick 1. But now we can find 27, the cube root of 27 from the table directly using the cube table. So in this table, the cube table, we come to the main header column, the main column. You find a number, you go and find 27, where we have 27 or 27.1, a number that is close. So first find for that number. So we have 27 here, where we have 0, we have 27.00. 27.00 is the same as 27. So you go back. What number is there at the x? It is 3.0. Therefore, the cube root of 27 is 3. Next, we want to find the cube root of 33.076 from the table, or using the table, because you cannot express this number in form of the prime factors. You cannot. Therefore, let us find 33.07 from the cube table. So you come here, you look for 33.3. Where do we have 33.3? 33 starts here. We have 33. So we have 33 where? Find for 33. We have 33.076. This is our number. So where did we find this number? This number was found in the main column 1. Right? The main column 1, that's where we have found 33.3. What is the value of the x column there? It is 3.2. So the number here, where this the square root of 33 point, this number is 3.2 and then 1. And then 1. So like this.